Hello friends, so once again welcome to my channel. In this video we'll start one new chapter, that is IO organization. Our course is COA. Hello friends, so once again welcome to my channel, and in today's video we'll start one new chapter in our course Computer Organization Architecture. The chapter is IO organization. Our course name is COA, that is Computer Organization Architecture. Inside your computer we have got the three basic components. One is your CPU, one is memory, and another is input output devices. So till now we have seen about your CPU. Inside CPU, your arithmetic unit, your control unit, and registers are there. Those components we have seen till now. Then memory also we have seen, and so the last component is your input output devices. So how processor is going to communicate with IO devices, that part we are going to see in this chapter. So here is, see, we have come across one word very commonly, that is peripherals. We used to say we are connected to peripherals. So what do you mean by peripherals? Peripherals are nothing but the external components connected to your CPU, which are not directly accessible to it. So see, CPU it consists of ALU, your control unit, register. Those are part of CPU. Then it is connected to memory via address bus, data bus, and control bus. And main memory is directly accessible to the processor. So apart from that, whatever we are connecting to the processor is not directly accessible. So those are termed as peripherals. So under peripherals, we can see input device, your standard input device keyboard, output device, then your storage device not directly accessible to the processor. So which storage device will be this one? This one will be the secondary storage, right? So see, next our job is in this chapter to connect the IO devices to the processor, right? And CPU cannot directly access the IO devices. In between, we require one interface. Directly, IO are not accessible to the CPU. So in between, we require this interface. So what is this interface? Why do we need this interface? That we will see next. So first I'll discuss, see, first point is interface is nothing but your interface consists of some software component as well as some hardware component. Your software component basically nothing but device drivers, right? So then the next point is, why do we need your interface? Why can't we connect processor and your IO devices directly? So there is a role of interface. Why do we need this interface? The very first point is, see, the CPU consists of, the CPU is nothing but a electronic device. Uh, the organization of CPU is totally different, and your input output device is your electromechanical devices. See, when we press key, then printer, so those are nothing but all are electro as well as mechanical, electromechanical devices. But CPU is completely electronic device, right? So when these two parties will communicate, whose design is different, then we need to convert their signals, right? One will speak totally different language and this one will also speak totally different language. So to communicate between this, we require one bridge, and that bridge is nothing but interface. So the first point is clear. Why do we need an interface? Peripherals are electromechanical or electromagnetic devices. My disk is electromagnetic disk, right? And their manner of operation is different from the operation of the CPU and memory, which are what? Electronic devices. So conversion of signal is required. First point is clear. And the another very important point, why do we need interface is, see, CPU is your a faster component and IO devices is a slower component compared to CPU. See, we used to say that my processor can perform these many MML, MFLOPS. That means X number of X mega floating point operations per second. We used to tell the speed of CPU like this. That means, see, mega means what? 10 to the power 6. X into 10 to the power 6 floating point operation the CPU can perform in 1 second. Whereas suppose whenever we are typing from the keyboard, How many characters we can type in 1 second? Let's say we can type maximum 50 to 60 characters. So 50 to 60 is a very small number compared to 10 to the power 6, that too floating point operation. Integer operations will be many more, right? So that comparison, you see that the speed of these two parties is very much uh, differing, right? So whenever two parties are communicating and their speed is different, then the faster component has to synchronize its operation with the slower one. So once I'll ask something from the IO device, it will take some time to give. So that time my another device has to wait for it, because instantly it cannot give. And suppose it has given something to this one, but it cannot take that one in that speed. So it will keep it somewhere, then the other side party will take it at its own speed, right? So another bigger difference between the two is of speed. And to manage that, we need to synchronize their operation. And to synchronize that, we have some components present in the interface, right? So data transfer rate of IO is slower than CPU and memory. So we require a interface. Second point is also clear. Another third point. See, the data that the CPU, means whatever operand the CPU takes, the way the numbers are stored for the CPU. Suppose I am storing one integer. That integer mostly CPU recognizes in your 2's complement form, right? And whenever you type some number from the keyboard, what it gives the ASCII code of the character. Suppose I have typed 12, right? Suppose I have typed 12, then whenever I type 12, it will come as what? One character 1, next character 2. Then it is internally converted into 12, and then only it is recognizable by the processor. So see, 1, 2, for the keyboard it is nothing but 49 and 50. What is 49 and 50? ASCII code of 1 and 2, right? It will come as a single character. That single character will be taken as a number by the CPU and will be doing the operations. So the way that the data codes and format in peripherals is different that from the CPU and memory. So conversion of format is also required. Third point is also clear. Another bigger point is also coming, that in our system only one that peripheral is not connected. Many peripherals are there. Your mouse is there, printer is there, then your screen is there, keyboard is there, your secondary storage device is there. So many peripherals are there, right? Then we need to synchronize their operation such that one should not interfere with the other, right? So that only I would like to mean. The operating modes of peripherals are different from each other. The way printer works in the same manner your hard disk is not working, and each must be controlled. So a peripheral should not or does not disturb the operation of other peripherals. All will be there in the system, and all will be coordinate, means all will not be disturbing each other. So why do you need an interface? The first point was that their manufacturing technology is itself different. The first point. Then next is their speed. Third one is that the way the data is taken by CPU and your IO device is different. And the fourth point is their operating modes are also different, and many more devices are there. So we need to coordinate between them so that it should not disturb the other. So for these reasons, we do need a interface. This is also a very important question. Why do we need a interface between your IO devices and your that CPU? Next is what is there in your IO interface. So in your IO interface, see, we are going to connect processor with your IO devices. So this side is my processor. It is connected through your address bus, data bus, and control bus to the IO interface. And via IO interface, it is connected to, suppose, one input device, one peripheral. Let's say this is an input device. So address bus is unidirectional, data bus is bidirectional, control bus is also bidirectional, right? So see, CPU will give one address. That address will be taken by the address decoder connected in the IO interface. Each device will have its own address. So whatever address is coming here, if it is meant for the device here, then only the device is going to respond to its read or write request, whatever is applicable to it. So here read request will be applicable because it is a input device. Then what it will do, it will send the data. The device will give the data. That data will be given to this buffer register. From this buffer register, it will go to data bus. Then the processor will take it. And whenever we are performing the operation, we may come across some error or we may perform it perfectly fine. So to indicate the status of my operation, whether it is done successfully or any error has occurred, then what type of error, some indication about that, everything we can get from the status register. So status register will tell us the status of our operation that is being performed. So by reading status register, we can understand whether the operation is done successfully or not. Then the control circuits are there to control the operations, right? And another one more is there, control words are there. Control, like status register, control words are also there. Those are also configured by the processor in the beginning to configure the device according to whatever way we want it, right? So in your IO interface, these components are there, and this, via these components, the device is connected to the processor over this address bus, data bus, and control bus, right? Then see here, what I have mentioned is that each device or each component inside a device is given a unique address. So next we will see the methods of assigning addresses to the IO devices. So that I will discuss in my next video. Hope this discussion is clear to you. Basically here what we have discussed, what is peripheral, why do I need interface, and what is an interface. So this much is there in this video. Thank you so much. Have a great day.